Let's look at the first of the homework mechanisms. We have a symmetrical anhydride undergoing a reaction with an alcohol, where the product of our reaction are going to be an ester and a carboxylic acid. This is a symmetrical anhydride, so either one of these carbonyls can get attacked, and that's going to lead us to the same products. So in this reaction, our nucleophile is going to be the molecule of methanol. Again, it can attack either carbonyl. In this case, it doesn't matter. So we're going to attack one of our carbonyls. That means that the first intermediate that we see is going to be this one. Now, this is the tetrahedral intermediate. And what will happen in our tetrahedral intermediates is that we'll always lose the best leaving group. In this structure right here, my best leaving group is this molecule of methanol that just attacked. So in order to keep this group bonded to that carbon, what we need to do is remove this proton. We need a base in our reaction to do that, and we can use a molecule of methanol to remove that proton, give the electrons back to the oxygen, and that's going to give me this new tetrahedral intermediate. Now, when this tetrahedral intermediate collapses, the best leaving group is going to be this carboxylate ion. So that as these electrons get attracted back towards that carbon, I'm going to kick out that carboxylate ion, and that's going to give me, as my first product, my ester molecule. The second product that I'm going to get out of this reaction is a carboxylate ion. This carboxylate ion can react with that molecule of methanol that we used previously to remove the proton over here. And so this carboxylate ion can take that proton from that molecule, give the electrons to the oxygen, and that's how I'm going to end up with my carboxylic acid as my second product. So overall, the two products that I get out of this reaction are the ester molecule that you see here and the carboxylic acid molecule that you see here. In this second mechanism, we now have a mixed anhydride. That means that we have two carbonyls that could potentially be the electrophile and two carbonyl groups that could potentially be the leaving group. That's going to give us a total of 4 products out of this reaction. So if we start this mechanism, the first thing that can happen is that my molecule of methanol can attack this carbonyl on the left. If that happens, that's going to lead me through my first mechanism, where the first tetrahedral intermediate that I'm going to form is this one here. I need a base in my reaction, like another molecule of methanol, to remove that proton so that that methoxy group is not my best leaving group. Now from this tetrahedral intermediate, as it collapses, it kicks out my best leaving group, which is this carboxylate ion. And that's going to give me one of the first products that I'll get out of this reaction. As this tetrahedral intermediate breaks up, my leaving group is this carboxylate ion. That carboxylate ion is going to take a proton from that molecule of methanol. That removed my proton previously in the reaction. So we can take that proton, give the electrons back to the oxygen, and that's going to complete my first set of products. So that in this reaction, one product that I'm going to get is that molecule of methanol. The second product that I'm going to get is this carboxylic acid. Now, because this is a mixed anhydride, we also have a second pathway that can happen. And the second pathway that we see in this reaction is where this carbonyl right here now becomes the one that gets attacked. So if we look at that mechanism, methanol attacks that carbonyl, and I'm going to get a tetrahedral intermediate. This tetrahedral intermediate looks like this. Again, I need to remove the proton from this methoxy group. And that now gives me this intermediate. From here, this tetrahedral intermediate can collapse. And as it collapses, it's going to kick out my best leaving group, which is that carboxylate ion. So that gives me my first product, which is the ester. Plus, I also get a carboxylate ion, which was my leaving group. So that one there. Just like we saw before, this is going to take a proton from my molecule of methanol. And what I get at the end of that step is the second product out of this reaction. So the two products from the second pathway are this ester and this carboxylic acid. Overall, in summary, we have a total of 4 products. The first pathway that we went through here, those products are shown in orange. That happened where the methanol attacked the carbonyl on the left, so that was my electrophilic carbon, whereas the carbonyl on the right became my leaving group in the reaction. And I got my ester from the carbon on the left and my carboxylic acid from the carbon on the right. In the second process that we looked at, we saw the opposite happen, where the carbon on the right was my electrophilic carbon, and the carbonyl on the left became my leaving group. The two products that I got out of that reaction were the carboxylic acid from my leaving group carbon, and the ester from my carbon that acted as the electrophile. Finally, in the third mechanism, we're looking at the reaction of a symmetrical anhydride with an amine. The two products that we get out of this reaction are an amide, and then we get a salt. So if we look at what happens, our amine is a very good nucleophile. It can attack either one of these carbonyls, and in the case of the symmetrical anhydride, it doesn't matter which one it attacks. So in this case, we can have our amine attack at this carbon here, push those electrons up to the oxygen, and that's going to give us our tetrahedral intermediate. So there's our tetrahedral intermediate. Whenever we have these tetrahedral intermediates form, we always want to be aware of who the best leaving group is going to be, so that at this point, if this tetrahedral intermediate collapses, we're going to kick this amine right back out. So we need to neutralize this charge at the nitrogen in order to keep this group attached to the carbon and get to our amide product. So we need a base in our reaction, like another molecule of our amine, to come along and grab this proton, give the electrons to the nitrogen. This tetrahedral intermediate will now collapse, and it's going to kick out our carboxylate ion as the best leaving group, and that's going to give us our amide product, and that's going to give us that carboxylate ion. This carboxylate ion is now going to form a salt with the ammonium ion that we previously formed over here. So overall, the two products out of this reaction are the molecule of the amide that we made right here, plus our salt that we see right here between a carboxylate ion and an ammonium ion. This reaction always requires 2 equivalents of the amine, because the first equivalent of the amine is what we use to form that amide product. The second equivalent of the amine is what's used as a base in the reaction, and we get that salt in the end.